Mike and Herman, can you say a couple of introductory words about your background and who you are, where you come from, and who are you, why are you here?
I just got referred to as dead. That might be because I'm old.
Who are you?
I'm Herman Story. I am an independent consultant now for the last 10 years since I retired from Shell. Worked 42 years for Shell. So been in the business for a little while. And worked at Shell. My last job, I was a principal technology expert for instrumented systems architecture, which had security and distributed control systems and field buses and all kinds of things like that stuffed into it. It was a grab bag of technologies. But been around this for a while, and I still like tinkering with it and talking about it, so it's fun.
I'm Michael Clark. I hail from Calgary, Canada, and my daughter phoned me this morning and says, "Daddy, I hate you." It's minus 39 in Calgary, so I'm happy to be here on so many levels. Thanks, Larry.
But the reason I have Mike and Herman here is because they have a lot of experience actually implementing these devices in the field.
Sure
and
do.
also through the years developing protocols like Foundation Field Bus and HARD and so forth. So we'd like to expand the discussion right now and talk a little bit about the role of devices in cybersecurity, and I think particularly intelligent devices, which according to our research, intelligent devices are definitely the majority of the installed base of all field devices in the process industries today. I think HARD devices are pretty much the default now. If you're going to buy an intelligent field device, whether it's a pressure transmitter or what have you, it's probably going to be a HARD device for the process industries, with all the onboard processors and network capabilities and so forth. So I guess just to get the conversation started, and we'll take questions from the audience too, but do we have any words of wisdom about, what can we do, as far as what end users can do to take concrete steps to increase device level cybersecurity, to maybe prevent things like this from happening? I mean, is there anything we can do? What can we do?
You want to touch that?
So you don't have any tools. You got procedures. Our field devices don't have firewalls. They don't have encryption engines. There's no authentication or authorization. When you hook up to one, it's anonymous access with unlimited privileges. That's where we are. That's the tools we have. So you have to kind of limit who has the tools, what's their training, what procedures do they use. Bear in mind, these tools don't have security in them either. So not only do the field devices not have security, but the handhelds and portables and all, most of those aren't secured, and they need files off the internet to go talk to the device. So like he downloaded a DTM and some packware, well, yeah, you go get that off the internet. You want to talk to a field device, you go get stuff off the internet. That's what you do. So now we have tools that are connected to the internet that we go and connect to our field devices. And how do you deal with that? It's all procedural stuff because we haven't been given good tools for security for our field networks, field devices, and it's tough on users. Are users worried about it? No problem. Apathy and ignorance win out every time. So nobody's worried about it, and we don't have tools to manage it. So the procedures and processes get kind of lax, and security things happen. I would say to you that most of the bad security things that happen are not from external hackers. They're mostly from Bubba out there doing his job. And he doesn't have the right tools and training to keep from making mistakes. Just, he's out there keying in a bunch of values and he keys in a wrong value somewhere. It's really easy to key degree C instead of degrees F, and I've seen it happen. Square root instead of linear. Happens all the time. And how do you find that? Well, you go back and back check it. It's extra work. That's it. Can you download a clean download to a device? Well, that might be harder than you think. So it's an issue, and it's a lot of procedural things that people typically don't worry about enough.
Mike?
So in my experience, I play a lot of training situations with big oil and gas. That's kind of my background. And so I'll be out at a facility and doing an audit, and we'll be looking at some of the instrumentation that they've got there and the standard operating procedures on how that they would do their calibrations. This gentleman here was talking about frequency of calibration, trying to keep the instruments, properly in calibration. The funny thing is, a lot of these places, they say, oh, well, we've got templates in our control systems, and we'll download those templates, and those templates have all of the parameters in them. It's like what Herman said. We think that we've got things downloaded correctly, and sometimes people hide behind the templating and say, well, no, we've gone to great lengths to build these templates, and therefore we're safe as long as we use that template to download to a device, we're fine. But then along comes these handheld instrumentation communicators. I've been in plenty of facilities where people have sheepishly come forward and said, yeah, we have a documented case where we actually shut down the facility because of using one of these. And everybody's really interested in their shoelaces all of a sudden because they're like, it wasn't me. People have gone to great measures to actually lock down the access to these handhelds. I know some facilities that have outright banned them outside of their instrument shop. So they're only allowed to use them on the bench. It just depends on what your stomach is for having people out there with this kind of power. And Herman's right, and we all saw it here. It's so easy for us to go in and change one parameter. So stealth mode out there, you got somebody that's disgruntled or whatever, and they want to go and change something, it would be so easy to do.
Yeah, I liked how you brought up, having the power in that handheld. And, in some respects, we got everything that we asked for because we keep asking for convenience and being able to reach these devices because they're 1,200 feet away. So Hart was an
Or it's
upgrade.
minus 39.
Or minus 39.
And I don't want to go
degrees.
outside.
There you go.
We made that request over 30 years ago. That's where Hart came from, is make this easier. Give us some alternatives to physically coming in contact with these devices. And I think, I might have this wrong, I think there's some analysts in the room that could give us the real answer. I think there's over 40 million Hart nodes that have shipped within the past 30 years. Anybody confirm that? There's a lot.
More than that.
Is it more than that?
More than that, yeah.
That wasn't even close. Minus 39
That was
degrees.
maybe-
I'm out of calibration.
Yeah, maybe 8 years ago, that might have been right, but it's a lot more since then, yeah.
Great, but that
Yeah.
just amplifies the point here. And if I'm not mistaken, so many of those devices are not even using that Hart capability.
At all.
So it's there for the taking. We can capitalize, we can benefit from that, but somebody else can capitalize on it and exploit that. So, I think about the convenience that we asked for 35 years ago, and then I look at today and the connectivity in today's systems, and now I'm thinking about a different situation that crops up because here again, we are striving for convenience. Now, reaching 1,200 feet isn't good enough. We want to be in our control room that's not even on the site. or we want to be halfway around the world and centralize all of our calibration. These are some extreme examples, but the architectures that we have today enable that. This concept of seamless bridging and routing is very real to reach the simplest of sensors, the simplest of instruments that are out there that are not inherently IP devices. We have come up with so many creative mechanisms of reaching serial devices and to do that from literally halfway around the world. So, I think like an earlier conversation we had about a big red button, if you weren't here for it, you missed a good reference to a big red button and a simpler time when big red buttons were valuable. I think we should be thinking about all the convenience we continue to ask for and the consequences that can come with that convenience. It can be good if we can reach, a device remotely, but at the same time, do we really need it? And I think we should think about need versus want. Sorry, I'm on my soapbox there, obviously, but thanks for listening. I guess you guys have to.
Good comments. Jeff, please.
I'll go quick because these guys need to talk too. So I wrote down actionable things. So boundary checking in the code. I think we'll get to a point where we'll want to do that. Some HMIs, some PLC sides, your boundary checking, like did something strange get out of range? The other thing is I wrote down rate of change. So a lot of these instructions have rate of change capabilities in them. So I've seen a step of X, and this is weird. So there are things that you can do. Last point is as we connect and actually have the devices participating in the communication diagram. So a lot of times you'll see communication diagrams. This server should be talking to this PLC. I think you'll get to a point where the device is talking to something else out of channel, out of bounds, out of band, whatever you want to say. I think you'll do communication diagrams for those things too. Yeah, drop the mic.
Do we have any questions from the audience? Oh, okay. I'll go back here first, and then I'll come and get you.
I just couldn't miss an opportunity, right? So,
Awesome.
previous life, working for one of the major distributed control system, DCS system vendors, and now, looking at kind of some of the architecture you've got in the demo where you've got a heterogeneous system with different manufacturers talking to each other, et cetera. Are there any advantages going to an integrated system where basically your DCS is the HART master and is configuring all your HART devices that are connected to it, and you've gone to that extreme step of outlawing communicators so that there is no sort of rogue, I guess, nodes on your network? I mean, does that help you or hinder you in any way? It's kind of like putting Doug on the spot a little bit, I guess, when we were, working on one, you're the PLC vendor, I'm the DCS vendor, and it seems to me that this is an area where a high degree of integration actually can give you some benefit.
Yes, it can, but it doesn't solve the problem. The problem here is that you need field communicators because there's things you need to do in the field. So when you put in a DP cell, you need to go out there and zero the thing. When you're putting in a valve positioner, there's several acts that you have to do at the physical device. So you have to work on it right there where you can turn knobs and adjust things and do stuff. And so you need field access. Simple as that. And it's not really effective to try to do it with one guy in the field and one guy in the house, and that doesn't work. You need the guy in the field needs to have access. He ought to have limited access, and we ought to know who's there, who logged in, what he's allowed to do. There ought to be authentication and authorization before that guy hooks up in the field. It's not there. But you need field access, and you can't eliminate field access. You could do a lot of neat things given a clean sheet of paper. You could have that field communicator talk to a host system. None of our protocols support that, by the way. Could, and you could use that field communicator to get the host to download a device when it's ready. There's a lot of neat things you could do. You could use that host system talking to the field communicator to authenticate and authorize. You could do lots of neat things with a clean sheet of paper. We hadn't got a clean sheet of paper. We got millions of devices installed that can't be fixed because they run on an ASIC and you can't patch them. And so we got to have good procedures to deal with what we've got. And I think we need to move to something better. But moving to something better is not going to happen quickly or easily. Somebody's actually got to start working on something better, which I hope they will. And users have to be convinced that they should buy something better, and vendors have to make a buck at it. And this is a complicated problem. This is a business problem as much as it is a technical problem.
Let me take a stab at it, Marty. It's a good question. There are vendors out there that would like you to think that using an integrated solution, their integrated solution, is a better choice. There are some bells and whistles that come along for the ride. I will not discount that. But the fact remains that I still have profoundly beautiful access to all of these parameters. And if I'm having a bad day and I want to go change those parameters, I can be just as stealthy as the guy out in the field. Doesn't matter that I've got somebody's integrated package. I can still go and mess with it. That's just, you know, if somebody tells you that that's a better choice, then they're selling something. Oh, wait, they are.
Doug or Jeff, pass on this one?
Yeah, we can
Yeah.
pass on it. I mean,
Okay.
I think they've.
Yeah, no, those were good comments. Any other? If you don't mind passing it down.
So my question would coming back to the ones we deferred earlier about if the crown jewel is the data table in the PLC. And personally, I believe the PLC is much easier to get to because it's Ethernet connected than an OPC or a hard network. Rockwell made a really feeble attempt in the PLC 5 series to provide passwords. Like, I think they allowed 4 levels of passwords based on the COM settings you could lock down. And then they did away with that. So do you have any input of any vendor possibly considering actual password protecting and audit trailing access to a PLC?
Yeah, so it exists today. I mean, I don't know. So the in that particular case with that particular vendor, the PLC participates in the challenge. So first of all, the design tools have user rights and privileges, username, password, whatever. It communicates that down to the PLC, and the PLC has a kernel in it that says, does this person have this authority to do these actions? Like, can I download? Can I change the firmware? Can I make changes? Is this a read-only copy that I'm actually accessing? So the answer is yes, today there are vendors who actually do have that granularity. So SIP is what's running inside those, inside most, or not most, inside Rockwell's platform. It's like SIP. You mentioned PLC 5s, which was PC cubed. This is SIP. So it has the ability to know what tools it's talking to, but I think there's further strides they can do or that they could do in that realm. Now I'll shut up on that one. So there are capabilities inside the PLC today to do what you just said. I think it will get stronger and stronger for tool authentication.
Yeah, I certainly don't want to add much more here because I'm not a representative of Rockwell Automation either.
Yeah, I'm not.
Perhaps somebody is here to represent Rockwell. But in a very general sense, that's a recognized issue is, in an IT world, a business enterprise, there's this concept of group policy, of managing privileges and access rights. That's a very developed idea that's implemented in the business, operations systems. Those same concepts are definitely being explored, being implemented. Some of those exist today, but then there's another side of this equation, which is when you pick up the glossy that is promoting the product that it has all these features, are you actually following through as end users to make use of these capabilities? Do you fully understand what's available? Are you applying those? And I'm not placing blame here, but are you testing, what is being marketed to you? And are you providing input back to the vendors to say, while this is a good idea, in practice it just falls apart because it's completely unmanageable. Great example is building trust in the devices that are connected to an industrial network. Well, how do you build that trust? You need to have some type of an authority to basically a third-party authority of sorts to verify that there is trustworthiness of these devices. Well, where does that authority live? In the world that we live in, when we jump onto our browsers, that's somewhere else on the planet. Are we willing to open up holes in our control architecture so we can reach somewhere else on the planet? Those are the types of issues that have to overcome. I noticed that you were shaking your head a particular direction there. There's probably somebody I didn't see that was shaking it in the opposite direction saying, yeah, we're doing that already. We have opened up holes so we can reach a certificate authority, while somebody else is saying, no way in heck am I gonna pop a hole in my firewall just for that. So where does that lead us to is these technologies are being delivered by a number of vendors, but it doesn't necessarily mean that they can practically be applied. Doesn't mean that we're ready for it. And that readiness also includes thinking through 20 years of commitment to what that implementation is that I'm signing up for. So
we're kind of dancing around the whole network management topic, which is one of my favorite things to talk about. Network management gets into who's allowed to talk, what are they allowed to talk to, what rights and privileges do they have, how do you authenticate them, all that kind of stuff. So it encompasses all of the security and management. And it also, in a lot of networks, covers schedule and time distribution and other stuff. So good stuff. We don't have network management in our process control systems to any great degree. We have little bits of it. Before I left Shell, several years before I left Shell, we decided that all of this patching and virus protection just wasn't cutting it for our desktop systems, and we went to whitelisting and lockdown. And we used two-factor authentication to get on the network. Sometimes we used three-factor authentication. We got pretty serious about it. And it worked. You could actually protect your systems better with whitelisting and lockdown than you can with reactive measures like virus scanning because you can protect against zero-day exploits. And after working with it on our IT networks for a while, we decided, this would probably be good for our process control networks too. I've confirmed as of today, we haven't gotten that done yet because we just don't have the support we need to lock down our process control networks. Even though we decided years ago that it was a good idea, the infrastructure isn't in place and it's hard to do. And we don't have the IT skills in our process control group and the quantity of people and everything else it would take. So we have unlocked networks, poorly secured networks. That's commonplace in our process control systems. And we're still trying to depend on virus protection and patching for the PCs and nothing for our field networks. We don't check for viruses, we don't authenticate and authorize, we don't do anything. It's just wide open. We could do better than that. We should do better than that.
Okay. I'm curious about your thoughts on wireless heart. You know, it's a growing, emerging market. We've got millions of hardwired heart devices, and what your comfort level is with the use of these devices, and where would you deploy them, if at all?
So when I say our networks all have a lack of authentication and authorization, when you're talking to the device and doing configuration, that's universal. That is every network, whether it's wired or wireless. And that does include wireless heart. So there's a back door to every wireless heart device where you can walk up with a communicator and do whatever you want. And the wireless part doesn't know a damn thing about it. The wireless part is secured for moving a process value from a device to a host or to a gateway. It stops at the gateway. If you change protocols at the gateway and talk to the host with another protocol, that may or may not be secured. Probably isn't. So wireless heart, they've got a wonderful job of securing the wireless movement of the process value that's done kind of in the same way that safety bus standards are written to protect the process value on a safety bus, like a ProfiSafe or something like that. You can move data from here to here and it's protected. Once it gets past here, who knows? But the configuration of the device is never, ever protected. Anywhere. There's always a back door where you can get to it with a handheld or something and reconfigure it.
The only other thing I would add to that, you know, just full stop, that's perfect. The only other thing I would add to wired versus wireless heart is that with wireless, I add another level of denial of service. I could jam the signal.
That was perfect. I'm going to add one thing. It was, guys, seriously. To your question about wireless heart, what immediately comes to mind for me is an expanded accessibility. Now I don't have to be, I can be in a proximity. I don't have to have a physical connection to a wire to reach that device. Clearly that's a concern. I'm going to address your question with something other than wireless heart, though, because there's another movement in the heart movement, which is heart IP. And heart IP is encapsulating the heart protocol inside an IP packet, and now you can be halfway around the world moving heart commands through any architecture, including wireless. Here again, somebody in this room asked for that, so guess what, we got it. I'm not saying that it's bad, but there's responsibility that comes with that. And when to your question about wireless heart, I would look at the concern around this just being a little more expansive than the airwaves that I may or may not be able to control with the amount of power I'm pumping out, or the environment that it's in. I think in general what we should be thinking about is just these devices that historically had been electrical devices, not logically connected devices. We extracted information electrically from them, is what I'm trying to say. The whole world is changing, and we have plus 40 million of those devices at minus 39 degrees
Nice.
somewhere
Somewhere.
out there. So I realize I didn't answer your question, but I'm just expanding upon your question that there's an even more contemporary movement than wireless heart that's taking us down an increased risk path that I'm not convinced that we've really thought through what the ramifications are.
I just want to dogpile on that, and the question I have is, did we ask for that? I don't know that I did. I'm a little bit of a troglodyte when it comes to, innovation for innovation's sake. I love locking things down and having security and safety and knowing where the holes are. I don't like adding additional holes to my system, and anytime you start talking about making things IP enabled or giving me wireless access to things, your little demo where you could just wirelessly walk up or Bluetooth or Wi-Fi, pick your poison, that just, makes the hair stand up on the back of your neck. Did we ask for that? It's a good question to ask yourselves. Did you ask for that?
Thanks for the panel explaining all the risks that we run these days with HART and wireless HART. Is the panel familiar with any incidents that we have had in our industry, except the incidental ones where somebody screwed up with a number, that people did really something on purpose to create damage? I mean, there are plenty of big holes now, so somebody must have used it.
Yeah, Stuxnet.
Oh,
You
you owe
said
me a
it first.
dollar. You said it.
You said it. No. Go ahead.
Well, it's somewhat of, it's a more extreme example than what this demonstration stood for. But if we go back to the Stuxnet attack, for instance, the drive was part of that attack vector that was lying to the system, that was misrepresenting, the data that was misrepresented to the operators. The drive was under control. That's an actuator in the system. It's an I/O device, a little more complex than a thermocouple or some of the simpler instruments. But that's one real world example where we know there was a malicious intent behind that. Short of that, I can't directly point to anything, but I think as part of you articulating your question there, is it any less of a risk for us to think about the potential mistakes that, I used a J thermocouple when I should have used a K thermocouple. Does that make sense?
Yeah.
J and K? Okay, good.
Yes.
Good. Those are real world examples, right? Or I miscalibrated something into centigrade when it should have been Fahrenheit. We can. I think we're going to see examples in our future of malicious attacks, but part of our security objective isn't just to protect against the malicious actor, of course. And that's part of what we're trying to bring to the surface here, is that protecting the system is protecting the system, regardless if it's a malicious actor or the most trustworthy actor that has just made a human mistake.
That's fair.
So one that comes to mind is misuse of tools was the old Vitek Bowden case a long time ago. Yeah, there you go. It's disgruntled. It's a use case. Disgruntled person uses authorized tools, or at that point it was unauthorized tools. Backed sewer up 24 times into a hotel, and they finally caught him. So that was one misuse of tools. But we also do one in the power sector we show the Ukraine grid attack. So we show HMI, we show remote, the PLC, and we show breaker status. And basically we do a man in the middle where we're lying what the breaker status is from the PLC comms to the HMI comms. So, and again, that was a real world situation where, actually occurred. And so while it's not exactly instrumentation levels, it is lying from PLC to visualization, so those are the ones that always just pop in my head because.
Yeah, and if just one quick comment, the intent behind the demo wasn't to describe what has happened. It's just to highlight what could potentially be misused. Living off the land and the environment. Here what Jeff is demonstrating is that somebody could take advantage of this, either intentionally or accidentally.
I've run into a bunch of users, it's commonplace, that have the perception that the way to secure their heart is to keep it out of systems. No connected systems anywhere, no heart modems, just they're all isolated. And we don't talk to them with anything but communicators. That's their idea of security. And I've actually seen that done, and it's done fairly commonly. And a couple of things happen with that. One is they're doing all the configurations with a handheld and they're fat fingering in configuration, and people make a lot of mistakes. How many mistakes? Several projects we went through and just back-checked initial configuration using handhelds. About 10% of the devices had errors in configuration. These guys had the right information, they had the training, they had a communicator, they knew what to do, they made mistakes. They misspelled the tag name, they got a square root where it should have been linear, lot of stuff, degrees F instead of degrees C. Very common. You can go read them in, back check them. You're going to have to go to the field and clean them up. I went to did another audit. I didn't do the audit. One of my buddies did an audit of a unit that we had put in and run for 6 years. And we had done the back check and cleaned them up, but we were using handhelds to do all our maintenance, not using the system. Even though we had some heart modems, there were issues. We had one modem for 300 instruments. That was the issue. Doesn't work. Well, after 6 years, about 300 of these devices, we had something like 30% of the devices had configuration errors. These are devices that are inputs to safety shutdown systems. If you feel comfortable with 30% of your safety system inputs having a configuration error, I don't know what world you live in. I don't feel comfortable with that. But that's where we were. Another thing that happens, and I can tell you about an incident associated with it, is since they're not being monitored, there's no system there looking at them, these devices find errors, they find problems, and they try to tell you about their problem. So we had a valve positioner on a recycle valve. It was an anti-surge valve on a compressor that it was getting sick, and it was telling us about problems, and there were errors stored in there for a good month. It was telling us, I'm getting sick. It finally got dead and kicked the valve open and shut down the plant, and it cost us quite a few $1 million in actual process loss. It cost us a multi-million-dollar fine because when the compressor went down, we went to the flare, and we were under a consent decree from a judge that we wouldn't flare. The judge seriously considered shutting down the refinery permanently. This is a refinery that was making $1 billion a year profit. Not income, profit. You don't want to shut down refineries that make $1 billion a year profit and keep a couple of thousand people gainfully employed and contribute to my pension fund. Not having the diagnostics is a serious problem. And keeping those devices isolated deprives you of any diagnostics. So a lot of bad things happen when you try to isolate the devices and just depend on handhelds. It's not the answer. We have to find a way to make them secure with them connected up to networks.
Oh, we got one last question, Peter.
Is Peter going to try to make this more fun?
Sure.
Go ahead.
This, In fact, I don't have a question, but I would like to make a comment on your final statement. And this is simply, there are certain vendors who, once in a while at least, listening to their customers. And based on that, there are safety systems available who are able to utilize the hard information and who are, or that are able to act on this kind of disease autonomously. However, this of course requires an additional engineering task because the systems are not able to do this just on their own, but it needs to be pre-designed, pre-engineered, and the systems need to be prepared for that. But the technical solution is feasible. This is more or less day-to-day business these days.
Thanks, Peter. Okay, I think we're at the end now. So this may not have been the feel-good session that people might have been looking for.
I feel great. I eat cookies.
If we want to engage in some depression-fueled eating of chocolate chip cookies, we have some more cookies up here.
This is to
Yeah.
prepare you for a few drinks.
Yeah.
But I don't want to get the impression that we're here to bash any vendor or protocol or anything like that. I think, a big part of what we do here at the forum is to raise awareness of issues that people should know about and, start doing something about. So I think that's probably the message here. And if, the end users here go back to their plants and start trying to take some measures, to maybe prevent some of these things from happening, I think we've done our job. I think at the end of the day, at least from my perspective, we want to make things safer, and better. So I want to thank our demo people from Sands, Jeff and Doug, thanks a lot, and our esteemed panelists here, Mike and Herman. Let's give them a big round of applause. And thanks very much for your very intelligent questions. So we do have a reception tonight. We have a technology exhibit that I think is opening up, if I'm not mistaken. And we're going to have a reception, I think, until 9 p.m. tonight. And there's, lots of networking, and, I encourage everybody to stick around. And it's going to be a very good week. Thanks for coming.